Hello, my name is Chris Hybritz. I'm a Senior Program Manager on the Hyper-V team, and I'm excited to share with you some of the graphics and virtualization improvements we've made with Windows Server 2016 and how Remote Desktop Services is taking advantage of those. Before I share with you the technology, I wanted to first share with you how we view the users that use GPU virtualization. At the top of our pyramid, we have those power users who tend to consume the entire GPU resource. At the bottom, we have those users who need very little GPU resources and take advantage of technologies like multi-session or app remoting. At Microsoft, for Server 2016, we wanted to ensure that we had technologies that address this entire pyramid. And with that, we have our existing virtual GPU technology known as RemoteFX vGPU that we've improved that addresses segments of all of these levels. And we also added a brand new technology known as Discrete Device Assignment, which really is focused on this top user. However, I'll show you how it can also be applied to this bottom user as well. Let's switch over now to Windows Server 2016. What you see on my desktop here is a device manager in the upper left-hand corner to show you the physical devices currently present on the system, Hyper-V Manager in the lower left to show you the virtual machines we'll be interacting with, and PowerShell Editor on the right to show you the PowerShell we'll be using when we get to the Discrete Device Assignment part of this demo. As I mentioned earlier, there are a number of applications that don't require a physical GPU to be present, and for that we provide a software-based renderer that leverages the CPU to do the application's rendering. But what happens when you want to run an application that exceeds the capabilities of that software-based renderer? In this case, I'm going to run Firmark, an industry standard benchmark that wants to use OpenGL 2.0, something that the software-based renderer doesn't support. And as you can see, the application just doesn't run, and some applications, if they do run, will just run poorly. Let's go ahead now and switch over to RemoteFX. Prior to Server 2016, RemoteFX was limited to DX11 applications only. What we've added in Server 2016, though, is the ability to run OpenGL-based applications or OpenCL-based. We support up to OpenGL 4.4 as well as OpenCL 1.1. As you can see, the performance here is pretty good. We're running at 21 to 24 frames per second with this benchmark. Some of the other improvements with RemoteFX is that we've increased the amount of dedicated VRAM to 1 gigabyte, and we've added support for AVC 444 encoding to up the fidelity of the transport. I mentioned a new technology that we call Discrete Device Assignment. What that means is we're going to take a discrete device, in this case this NVIDIA Grid K2 card, and assign it to this VM. We're going to do that by using a little bit of PowerShell. The PowerShell is quite simple. The first part of it just goes ahead and sets up the VM to accept that device. The second part of it here dismounts the device from the host so that no one else can get access to it. And the third part of it adds that device to this specific VM. Let's go ahead and jump into this VM now. We'll open up Device Manager, and the first thing that you should notice is this device looks exactly like it did running on bare metal in the host within the guest. What that means is all the features and capabilities of that device are now present within this virtual machine. Additionally, if we run this benchmark, because the entire device is dedicated to this VM, we should get all the performance that this device can throw at us. So if we look here, the frames per second being reported by this benchmark are in the 47 to 52 range. Additionally, all the features and capabilities of this device are present, meaning things like performance counters can be leveraged, all the encoder capabilities or APIs that the hardware vendor themselves have created are now present within this VM. DDA is really to maximize your application compatibility as well as your performance. Up until this point, I've only shown you Windows 10 running as in the VM. Discrete Device Assignment and RemoteFX also work in Windows Server 2016. Additionally, Discrete Device Assignment works in Linux VMs as well. So as you can see here, I've Discrete Device assigned this NVIDIA Grid K2. If I run the same benchmark, what we should see is similar performance to when we ran in the Windows 10 VM. And as you can see, we're sitting at 46, 47 frames per second, much like we had with the Windows 10. One of the benefits, though, of running in a server environment is not only do you get graphics acceleration for the administrative account, but you could start setting up user accounts that are all running on the same virtual machine, the same server, and each of these user accounts, for the first time ever, now get access to that GPU resource as well. So as these benchmarks start running, what we'll see is the frames per second is now divided amongst all 4 of these instances. This really is targeted towards those scenarios where users only need part of the GPU some of the time. Additionally, this technology can also be applied to multipoint. So if I bring up my multipoint dashboard, I can see the other 3 users are currently using a GPU workload. I hope you'll agree with me that in Server 2016 we have a lot of exciting advancements in graphics virtualization. And with that, I'd like to direct you to Microsoft.com/WS2016 to find out more details about all the advancements we've brought for Windows Server 2016. Thank you very much.